Welcome, everyone. Thanks for coming. My name is Brian Welker, and I am a principal product manager on the Amazon RDS team. And as a product manager, over the last 3 or 4 years in RDS, I've gotten lots of questions from different customers, from partners, and last year at reInvent, I assembled some of those questions into a presentation to answer some of the most common questions that we get. And what I thought I'd do this year is sort of provide an update to some of those questions with a spotlight on the new features. Now, Amazon RDS, to date, we've done over 100 new features this year. Now, I know that there's new features all the time, but we're very excited about all of the new things that we've brought, both with core Amazon RDS, the open source and commercial engines, as well as Amazon Aurora. So I'm going to focus on a lot of new things today. I'll talk about configuring your database instance, getting set up, picking your storage, picking your instance type, and I'll show you the latest in our new console. We've made some changes recently to the RDS console that are pretty exciting. I'll talk about managing HA, high availability, for your database instance, how we deal with read replicas for read scaling and disaster recovery, and talk about how we manage backups and some of the new features in that section. Talk about monitoring and troubleshooting. There's a lot of great tools built into Amazon RDS for monitoring your database, seeing when things go wrong, and figuring out what to do about it. And then finally, I'll wrap up with how to save some money, how to optimize some of your database costs with Amazon RDS. As I mentioned, I'm going to spotlight some of the new features that we've done. So you'll see the little new purple icon there whenever there's something that's been introduced in, say, the last 9 months or so during this year. So hopefully you're familiar with Amazon RDS, but just in case, here's a quick update. Now, we built Amazon RDS starting back in 2009. The first engine that we built was the MySQL database engine. And the goal of RDS was to take the complexity out of running a relational database. We came up with the idea of running a database as a service in the cloud and really handle all the things like, how do I provision it? How do I get the OS set up? How do I install the database software? How do I upgrade the database software? So Amazon RDS really lets you focus on the things that differentiate you, not on database administration. And over the years, we've continued to add new capabilities and new features, as well as a big investment in our own cloud-native database engine, Amazon Aurora. So really the keys are easy to administer, so a single pane of glass, a single console for all your databases, easy to deploy, scalability to be able to scale up both on the storage side as well as the compute side, so super easy to scale up when you need more capacity. Highly available. I'll talk about how to set up your database for high availability through our multi-AZ, multi-availability zones, automated backups, automated snapshots, automated failovers, and then fully secure. Amazon RDS is secure by default. We configure things out of the from the beginning to be secure, but we've got lots of security features because we know that people's databases is sort of the core of their business. So let's talk a little bit first about getting started and setting up your database instance. The first thing you have to do is to pick which database you want. Now, if you ask 2 developers what their favorite database is, you might as well ask them, do they like tabs or do they like spaces? Everybody has their own database that they like, they've built apps on, they've gotten used to. And the good thing about Amazon RDS is that we support a lot of them. So you don't necessarily have to pick just because you want a managed database solution. I'm going to focus today primarily on commercial engines, that is the Oracle and Microsoft SQL Server, as well as the open source engines. There's lots of great talks on Aurora. They're all over the place. And so I encourage you to go to the drill downs on Aurora, but I'm not going to focus on Aurora today because I'm really going to focus on the other 2 segments. Now, both the commercial engines or the licensed engines, Oracle and SQL Server, as well as our open source engines, are based on Amazon EBS for storage. Amazon Aurora has its own purpose-built storage system that's just for Aurora, but the open source and commercial engines are based on EBS. The other thing about open source engines is that we're very aggressive about trying to follow the open source community. So both on the MySQL and MariaDB and Postgres front, we try to follow quickly with the updates and changes in the community. Now those updates take a little bit longer to get to our Aurora engines because we've done a lot of work there. So if you are really interested in trying out the latest version of Postgres or the latest version of MariaDB, then you can use the open source engines. As I mentioned, we're quickly providing updates. So these are some of the latest engines that we've provided. So in the MySQL space, we now have MySQL 8.0. It's a great release. It's got things like window functions. And most importantly, it's got a new crash-safe DDL operation. So in the past, if you were using MySQL and something bad happened while you were updating the data dictionary, your database could get into a corrupted state. With MySQL 8, they've made that transactional DDL operations so that you don't have a chance of having any corruption if something bad goes on. So a really nice release there. You'll notice there on MySQL 5.5, it is still supported today, but we don't recommend that if you're going to start now, don't use 5.5. It'll eventually go away. It's going out of support from the community, so eventually will disappear in Amazon RDS. For MariaDB, we have the new 10.3 release. 10.3 is another exciting release. The big thing there is an Oracle compatibility mode. So MariaDB has added a full PL SQL parser with a lot of features to mimic what you get in Oracle. And so, might be an interesting target if you're trying to convert off of Oracle today. Obviously, we also think Aurora is a great target for your Oracle migrations, but MariaDB is also an option there. For Postgres, we've actually released 2 versions in the last year, both 10 and 11. 11 is in preview, so we have a database preview environment where you can try out Postgres 11. There's a whole set of features in both of those releases. The big thing in the latest versions of Postgres and Postgres 11 is partitioning. Really rich set of partitioning functions. So if you're doing time-based partitions or key-based partitions, really nice partition management in the latest versions of Postgres. On the Oracle front, we support now 12.2. Not a lot of changes there, but just some of the way that they patch things in Oracle. And SQL Server, there'll be a new version of SQL Server coming out soon. We don't recommend, I think we've started to deprecate 2008 R2, so we don't recommend that you start up 2008 R2 if you're starting with SQL Server and RDS. But lots of great versions. Amazon RDS makes it really easy to upgrade, so you can just go in, apply the upgrade. We'll run the upgrade scripts. Now, upgrade is an offline operation, so we do take the database down because we have to change the data dictionary, and then we're going to apply those changes and bring it back up. Most minor versions just take a few minutes to apply. A major version will could take a lot longer, so you'll want to plan around any updates and upgrades. On both the MySQL and the Postgres engines, you can actually do minor version upgrades on a read replica, and then you can use that to switch over to minimize your downtime. So a nice technique for upgrading there. So the next thing you'll have to pick is your instance type. And we don't offer, Amazon RDS is based on EC2. We don't offer every single EC2 instance because we don't think they all work great for databases. But we think that really these 3 classes of instance are the best choice. In the T family is a general purpose burstable, so that means it has a sort of a standard ratio of memory to vCPUs. The M family is the same ratio, but is non-burstable, so you have dedicated vCPUs in the M's. And then the R family is a high memory configuration, so memory optimized instances there. We recently introduced for Amazon RDS, as you can see, the M5, so you can get up to 96 vCPUs now in an M5 24XL. The R5s are out now for Oracle. They'll come soon for the other engines. On the R5, you can now get up to 768 gig of RAM. Great for analytical workloads, so if you're doing big queries, and if you're doing high connection counts, really massive connection counts, the R's are great for that. I want to talk a little bit about the T's because we're about to launch the T3 support. And T3, if you have taken a look, is a great instance type. It's very affordable. It's less expensive than the M. And in T3s, we'll enable what they call unlimited mode. And so currently with T2s, it's a credit-based system. And when you run out of credits, your instance will drop to the baseline. So you have to be careful in the T2, if you're not in unlimited mode, of basically running out of CPU. Now, many people have workloads that are bursty. They're not running all the time. Maybe you're just running a reporting job. And the T is a great choice for that because it's affordable if you're not maybe running continuously. Now, in T3, you can, when you run out of burst, you can actually buy additional CPU credits. So you can go above your burst for the day and per vCPU hour charge. So you don't really have to worry about running out of CPU. You don't have to worry about your database performance going down just because you happen to use it a lot that day. So T3s will be out very soon for RDS, and we're super excited about bringing those to you. The last thing you have to pick for RDS is your storage type. We support 3 storage types today, but we really only recommend 2, which is either the general purpose SSD or the provisioned IOPS SSD. So both are SSD, they're very fast, very durable. We recently introduced the ability to scale up to 32 terabytes for Oracle, Postgres, MySQL, and MariaDB. So you can either create a new instance up to 32 terabytes, or you can take an existing one up to 32 terabytes. SQL Server still has a maximum of 16 terabytes. And we use Amazon EBS Elastic volumes. And what that means is that we can do these scaling operations online and pretty quickly. It takes just a few minutes if you want to go from, say, 12 terabytes to 14 terabytes. It takes just a few minutes. It's an online operation, so you can scale up your database if you're worried about running out of storage. Now, with GP2, the amount of IOPS that your instance has, the amount of throughput that you're going to have is based on the size of the volume. So you're going to get 3 IOPS per gigabyte of storage. So you'll have a minimum of 100 IOPS. That's below 33 gigabytes. Also, you have the ability between 33 and 3.3 terabytes, you have burst capability. So similar to the T2 bursting CPU, you can burst IOPS on GP2. Once again, it's a credit-based system. So if you're running GP2 and you're running, 100 gigabyte volume, and then you see your I/O suddenly drop out, you might want to go look in CloudWatch and make sure you're not running out of your burst balance. Now, above 3 terabytes, and then even higher than that, if you go up, you're going to get really good IOPS performance. We actually have now spanned the volumes in RDS and all the engines except SQL Server across 4 volume sets. So you're actually getting up to 4 times the throughput because we're using 4 volumes instead of a single volume. So you can get really good IOPS performance out of GP2. So sometimes customers will say, hey, I have a high-end workload. I want to make sure I have IOPS. And so I use IO1. But a lot of times you can just over-provision your GP2. Just go get a bigger GP2 volume, and it will do just fine. Now, if you do want sort of guaranteed IOPS, that's when you use IO1. So it's guaranteed to give you those IOPS performance 99% of the time. So if you absolutely want to make sure that you've got a certain amount of I/O, then you can go with the IO1. But we really recommend that you try out both. As I said, for many people, GP2 is just going to be a great choice. And I mentioned we do still have magnetic storage. It's still there. We do recommend people move off of magnetic. It doesn't support the scalable volumes. It only goes up to 1 terabyte. And overall, it's not as performant a product. So I'm going to show a little bit about the new, now that I've talked about getting your machine set up, I'm going to talk about show you the new console here. Let me switch over. So today we announced the availability of Aurora Global Databases, and with that came some console updates. So we've been working hard on the overall management experience, being able to launch your instance here. So this is the new experience. We've still got some work to do, and would like to hear your feedback. But what we've tried to do is we've taken our 3-page wizard and moved it down to a single page. So we don't sort of have this multi-page wizard to simplify that. You can still pick your the engine that you'd like and the version. And then we have a set of templates that say, here, what are the recommended settings for production or for dev tests? And so you'll get different sets of defaults depending on which one of these templates that you pick. We also give you more guidance around sort of your instance size. As I mentioned, we have standard memory optimized and burstable instances, and we give you a little bit more context about helping you make that choice. So all of this can be done, and then we've gotten some additional configuration down here in the this section. A lot of the less commonly used features, we kind of hid them so you don't have to look at them. So this is the new launch experience. We also have what we call a quick create. So quick create even makes it even simpler. It removes all of those choices, and all I have to do is pick an engine, and then I pick a size. So all I have to do is pick a size, and we've kind of configured a small, medium, and large size here. So I'm going to pick a small one, and you can give it a name. We'll generate a name for you, and that's it. You can just say create database if you want to get up and running really quickly. You don't even have to type in a password. What we do is we will generate a password for you, and so you click this link, and it'll say, hey, here's your master username and password. You want to copy this down? I'll delete this later. And it creates your database here. So you can see down here in the list, I'm creating a MySQL instance here called MyDatabase2, and that'll be up and running in a few minutes. The other thing I want to mention here is you can see we've integrated what we had when the cluster view and the instance view. In RDS, we had a list of clusters for Aurora, and then we had a list of instances for both Aurora and RDS. And we've collapsed those into a single view called databases. So you can see here, this is an Aurora cluster with a single instance. So you see a cluster here and a single instance. You can see all your database instances. This is actually a read replica of a MariaDB master there. So you can see master and read replica. And so you get a single view of all of your databases. I even have here an Aurora serverless database down here. So you don't have to sort of switch back and forth between instances and clusters in order to see all your databases. If I drill into one of these, so let's go into, let's see this MariaDB server here. We've also reorganized the detail page here to give you more information. It was getting really, really long with all of the information, so we've broken it out into a set of tabs here. I think my database is done. So we've broken it out into a set of tabs for connectivity, for configuration, backup, and maintenance. So trying to organize the information to make it easier for you to see. If you're actually drilling down on an Aurora cluster, we even give you the cluster topology here, so you can see and you can switch between the different instances in the cluster and look through them without having to navigate back to the list page. So some new features to really to make the RDS console even easier to use. I think I'm back up. Another exciting thing that we've recently announced, just in preview as of yesterday, was the ability to run RDS in your own data center. Sometimes customers will say, hey, I really like RDS. I like the idea of a managed database. I like taking care of all of the patching and versioning and provisioning. But I've got databases that I don't necessarily want to put into the AWS cloud. Maybe it's not right now, or more sensitive information. So we've announced and launched a preview of Amazon RDS running in vsphere clusters. And really you get the same characteristics that I talked about in RDS, that automation of the database, cloud backups and scaling. as well as the ability to easily migrate. So one thing you can do with Amazon RDS for VMware is you can actually run the database in your data center and replicate up to the cloud. And so if you're planning a migration, that's a really nice way to sort of bridge the gap between what's running locally and what's running in AWS. You get the same management console, so if you go to your RDS console, you'll see your database is running in AWS as well as running in your own vSphere cluster. Read replicas, performance monitoring, the same characteristics you get in RDS, but running on your own hardware. We'll support MySQL and Postgres in the preview. We'll eventually get to all the open source and commercial engines. So how does this work? So the first thing you do is you get RDS from VMware set up, and you deploy something called the connector. And the connector is the bridge between your vSphere cluster and AWS. So that's the thing that basically handles the traffic going back and forth. And there's a dedicated VPN tunnel, so all the information, all of the operations that I'm doing in the console, the APIs that I'm calling, all of that gets pushed down into my, my data center. And then in your data center, we're using the standard vSphere cluster to spin up instances, to spin up read replicas, to handle backups. You can do backups both locally within your own data center, or you can push those backups to the cloud. So a nice way to get a hybrid environment that we talked about this morning, you know, for customers who are running on both on-prem as well in AWS. There's a session tomorrow if you want to get a lot more details on Amazon RDS on VMware. So configuring HA, high availability in Amazon RDS is very easy, and our goal was really to make it a single push button so you didn't have when you went to production, that it was a really easy choice to make. So multi-AZ configurations take your entire database and replicate the stack into a second availability zone, a second data center. And now each of those copies is managing a full EBS volume with a copy of the data. And that data is kept up synchronously. So you can be guaranteed that any writes that you make in the primary are replicated into the secondary. So you're not going to lose any data if something happens in the primary, to the primary instance or the data center overall. Now, when it's running, the instances are being watched or being monitored by an external observer, and it's making sure that keeping track of who's in charge. So let's say your application here on the right, your application is talking to the primary, the master database, that's replicating over to the standby, and then the primary disappears. Maybe there's a volume failure, or there's a network span outage, or something happens to the instance, an infrastructure problem. So you'll get a disconnect. We will then promote the secondary to become the new primary, and then we will set backup replication because we want to get it back into a high availability mode. So we'll set up replication back to another availability zone. We'll spin that up, and we'll start replicating back. Now that could be the same instance that is now recovered, so we can use that with the same volumes, or it could be a new instance. So we'll spin that up and get it configured to make sure that you're not losing any of that availability. Your application then goes to Route 53, asks for what's the address of the database, what's the IP address, gets that new IP address of the new primary, and then connects to that. Usually this takes about a minute to a minute and a half for the full failover. One thing in multi-AZ configurations is that the database is not running on the secondary. That's one of the misconceptions sometimes people get. The secondary, we don't really start the database until the failover occurs. So it does take a little bit of time to start that up. And that's different, for example, in an Aurora cluster where the secondary, the standby instances are always running. They're running and connected. In a multi-AZ configuration, we don't launch it until the failover happens. The other thing that you'll want to do is if you're using multi-AZ, you'll want to make sure that your applications have the time to live on the DNS entries very low. I think we usually recommend about a second. So that's so they can go back to Route 53 and get the new IP address in the case of a failure. The last point here is that this is really about handling infrastructure issues, networking, storage, compute. It's not database engine problems. So if the MySQL engine or the Postgres engine, say, a workload related runs out of memory or has a bug in the open source engine and falls over, that's not going to trigger a multi-AZ failover because it would just fail over to an instance that is basically in the same situation. So we don't trigger that for database engine specific thing. Rather, we trigger that for infrastructure issues. Another feature that Amazon RDS makes easy is to gain read scalability. So let's say you've got an application and you're doing reads and writes to your database, and you're starting to see some peak on the CPU, and you're starting to see some slowdown. What you can do is you can spin up a read replica. The EBS-based engine support for Postgres, MySQL, and MariaDB support up to 5 read replicas per master. You can see that it's asynchronous replication, so you can monitor the lag, which is the difference between the time I write something on the master to the time it comes up on the replica. So you can watch that in CloudWatch. And then you can use that read replica for read scaling, for big queries that you want to run. So you can partition your workload and use that read replica. We have just recently launched a read replica for Oracle Enterprise Edition. That's in preview now. It uses a data guard, but it uses the same infrastructure, so now you get the same read replica capability that you do with MySQL, MariaDB, and Postgres. We will also be doing the same for SQL Server very soon. So we'll be using the always-on technology in SQL Server to provide the same read scalability for SQL Server. So we're excited to be able to launch that. Another great use of replicas is for disaster recovery. So the one I talked about before was primarily for an in-region. So you've got an application, you're running against multiple replicas in the same region. Could be in the same AZ or could be across AZs. But you can also use cross-region read replicas for disaster recovery. And what this does is allows you to keep a hot standby of your database in another AWS region in the case of a disaster. Now, with read replicas, we don't promote automatically. So we leave that up to you because it's an expensive operation to move your entire infrastructure over to another AZ, right, or to another region, right? If you're moving from US East 1 to US West 2, it's a pretty intrusive operation. But what we do allow you to do is to configure that read replica for multi-AZ, so that if you do have a disaster and you want to switch over to that other region, that read replica is already configured for high availability. So you can see here what you're actually getting in that configuration is 4 copies of the data. You've got 2 in your local availability zone, your local region. So region 1 here has 2 copies using multi-AZ, and then has a read replica with another copy. So you're actually getting 4 copies running in across both regions. And this is also a way to, you can use a feature called delayed replication in MySQL. And that's really good for self-inflicted problems. So what you can do is you can say, I want the read replica to be about an hour behind the master. I don't want it to be right close to it. I want it to be an hour behind. And if something really bad happens, let's say you drop a table accidentally or you delete some valuable information, you have this sort of a logical corruption, then you can go and you can use that read replica that has a lag to it, and you can stop it just before the bad thing happens, and then you can start using that and recover. So some nice features there for the MySQL engine. For Oracle and SQL Server, because we don't yet offer cross-region read replicas, we really recommend that you use cross-region backup copies. And I'll talk a little bit about that in the backup section. But what you can do is have a periodic job that pushes off those backup copies to another region, and then you can restore it out of that region if anything happens. So I mentioned backups, and RDS has sort of 2 classes of backups. We have what we call automated backups. And automated backups, you just turn them on, and then you can restore to a point in time any time in that window. So by default, it's 7 days. And you just say, I want to keep 7 days. And you can go back 3 days. You can go back 3 days and 6 hours. You get a full ability to rewind and restore from any time in that window. We also support what we call manual snapshots. And those are single points in time. And you take a snapshot of your database, and you can keep that as long as you want. And you can always restore to that particular point in time. Now, in both of these cases, we use S3 to actually store the backup. So we're storing a snapshot, plus we're storing transaction logs. And usually the transaction logs for point in time are within about 5 minutes of the backup, right? So you can use that point in time restore up to about 5 minutes ago. We have a property on the instance that will tell you what the latest restorable time is. So that's really useful to see if there's any lag in those backups. Now, for backups, there's no performance penalty, especially if you're using multi-AZ configuration. So what we're doing is we're taking the backup, the snapshot, off of that secondary instance. And so there's no impact at all to the primary. If you're just using in a single availability zone, we do have to pause for just a few seconds so we get a consistent snapshot between all of the volumes. But so you'll see a little latency when we take the backup, always in your backup window with a single AZ. And then I mentioned that you can copy snapshots across region. You can copy them to another account if you want to for safekeeping. Some of the new features that we've introduced recently, one's called retain automated backups. So today, or up until recently, if I delete an instance, its automated backups just went away. And one, that surprised people, but two, sometimes people make mistakes and they want to actually retrieve their data. So we now have the ability to retain the backup even after you've deleted the instance. And I'll show you how that works in just a sec. Another couple features we've added are the ability to specify your parameter group values during your restore. We always pick the default parameter groups. Now you can specify them. And the last one is important for people who are using another region for disaster recovery purposes, and that's incremental encrypted snapshot copy. So if you've got an encrypted instance and you're doing backups, if you copy those backups to another region, it's done on an incremental basis. So only the blocks that have changed since the last time you took that backup are copied. So it really reduces the size of the backups in the other region, which you're going to be charged for. So if you're using encrypted databases, you can copy those across and just get the benefits of incremental storage. I'm going to show you really quick how this works. Let me switch back over. All right, so I've got my databases view here, and let's say even though I've got MariaDB prod server here, it has the name prod, I'm going to try to delete it anyway, and I'll say delete this instance. Now, in this case, I've actually enabled another feature called deletion protection. And deletion protection is a way to flag an instance to say, hey, this is a production instance, and there may be multiple other instances in this count, but I don't want to delete this one. So what I'm going to do is I'm actually say, no, I really want to delete this. I'm going to go in and modify, and we're going to turn off deletion protection. And we'll just scroll down here. And we'll say, nope, I'm going to turn off deletion protection. And I'm going to say, do it immediately. So it'll now update that, and we'll turn off deletion protection. It may take a second here for the workflow. So this time when I'm deleting it, because I've turned off deletion protection, I got a couple of options here. One is, do I want to create a final snapshot? So a final snapshot is sort of just before delete. We're going to take a snapshot and store that away if you ever want to get it back. Sometimes the database is in a state where it can't take a final snapshot. Maybe there's a modify going on or some other problem. So sometimes people will turn that off. But then I also have this flag that says I want to retain automated backups. So that says, do I want to keep that point in time window even after this is gone? Now I can say, no, look, I really want to get rid of everything. But in this case, I'm going to say I'm going to retain my automated backups. I'm going to say delete me. And so we'll launch the backups, the deletion process here. Now, there's a new tab on the console here called Automated Backups. And Automated Backups is both backup windows that are active. So these are all my active databases that are being backed up. And you can see here for these databases, what's the earliest restorable time, and then what's the latest restorable time. So what's that backup window that I can restore from within? And I've also got a tab here called Retained. And Retained shows me backup windows that are still existing, even though I've deleted the instance here. So I've got one here that's called MySQL 570B, and you can see up here we're in the process of retaining the automated backup. So what's going to happen is during that delete, we're going to move the MariaDB. Oh, I think it might have gone over. Yep, it just moved over. So now it effectively went over to the list of retained backup windows, retained automated backups. So think about it as sort of a recycle bin for your RDS instances. And you can go back, and now I can say, I want to restore this guy and restore it to any point in time of that original backup window. Now, those will eventually age out. So if I was keeping 7 days, then after 7 days, that window will have gone away and it will be deleted. I can also explicitly just get rid of it if I don't want it anymore. But it gives you a chance to sort of go back and get your data if you happen to make a mistake. What's that? It's not a permanent retain. It will just keep it for the existing window. So if you had 7 days before, you have 7 days afterwards. And then it will eventually age out, just like it would normally. So let's talk a little bit about monitoring and troubleshooting. There's a lot of features built into RDS to help you figure out what's going on and make sure that everything's going well in your database. We provide free automatic CloudWatch metrics. So we, by default, push up important metrics about what's going on the instance, CPU utilization, storage utilization, memory utilization, your I/O and latency. So all these metrics are going up. There's a great new feature of CloudWatch metrics that you get a default dashboard for RDS. So if you're not sure about how to build a dashboard and which things you should look at, CloudWatch now has some out-of-the-box dashboards that are sort of geared towards each service, so you can take advantage of those. You can also set alarms on those metrics. So if you've got a connection spike and you've got high CPU utilization, that's something you probably want to look at. So you can set an alarm, set a threshold, and then get a page or get an email, get some sort of alert in the console if it exceeds that threshold. We also have what we call enhanced monitoring. And enhanced monitoring is an additional 50 metrics that have additional things about what's going on the database host. So more detailed metrics, a lot of sort of internal metrics from the operating system level that help you debug when your database is slow or something you're getting errors back. You can enhanced metrics are available. And that's at a very low level of granularity, up to 1 second intervals. So you can get down to the second. CloudWatch is usually in a 5-minute interval. We also have integration with many of the third-party tools that support in the AWS ecosystem for both CloudWatch and enhanced monitoring. Now, if you're troubleshooting performance problems, then we have a new product called Amazon Performance Insights, new feature of RDS. Originally, it came out for Aurora Postgres. It's now available for all of the RDS engines with the exception of SQL Server. SQL Server is coming. So it's available for Oracle, MySQL, MariaDB, Postgres. So, and what Performance Insights does, it helps you identify bottlenecks in your database. And it does this through sampling an agent that's running on the database, and it's looking at what are the queries that are running. And it's doing some sampling, and it's saying at this point in time, here's the queries that are running, and here's what resource they're blocked on. What are they waiting for? Are they waiting for CPU? Are they waiting for another, are they blocked by another thread? Are they waiting on I/O? Are they I/O bound? So you can see within your database sort of what's going on. And then you can slice down, you can drill down to the actual SQL statement. So let's say you put out a new version of your application, and it used to be that it was hitting an index with a certain query. It's not hitting that index anymore. You would see then in Performance Insights, you would see the computation time would go up for that particular query, and you could go in and maybe add an index or tune it in some other way. You get, by default, you get a week of data that you can slice. So even if something bad happened and then it's not happening anymore, you can still go back in time and figure out what's going on. You can look at that adjustable time frame. As I mentioned, we added support for Postgres, MySQL, Oracle. We can also, if you want to, you can have what we call extended data retention. So most people, a week is perfectly good. They don't really want to look at data past a week, but you can actually keep up to 2 years of performance data. So maybe you want to look at historical performance and you want to compare it to what you've got now. So you can actually store that data away for a little bit additional charge and analyze month over month. Maybe you've got a monthly job and you want to track trends over time, compare how the performance is going. We also added recently the database load metric, so that's sort of what's going on in the database, called DB load. That now is available in CloudWatch, so you can monitor that from your CloudWatch metrics, CloudWatch alarms. So DB load, and then split down by CPU and non-CPU. So what part of the load is attributed to CPU blockage, CPU weights, and what part of it's non-CPU weights. And we added the ability to include that in your CloudFormation template for your RDS instance. Another feature we added was what we call RDS recommendations. And we found that in looking through some of our support tickets and support cases, we found some common patterns. And what we wanted to do was to provide a way to give recommendations and say, hey, your configuration or your usage maybe is not following best practices. We find that databases that look like this work a little bit better. So we've introduced something called recommendations, and what it does is it analyzes your configuration, looks at your what you're running, and then provides some recommendations to you. And then displays that in the console. You can take action on those immediately. You can say, yeah, I'm going to do that. I'm going to follow that recommendation, or you can defer it to later, or you can just dismiss it and say, nope, I know what I'm doing. I'm going to just run like this. In the future, we're continuing to work on additional recommendations, so things like parameter values that are not recommended, performance recommendations, so using the data from Performance Insights to be able to say, hey, you've got a performance issue here, maybe you should scale up your instance, or maybe you've got plenty of capacity, maybe you want to scale down your instance. So those will be coming in the RDS recommendations. So database log files are another important indicator of what's going on in your database. So each engine will output log files, typically an error log or a general log, and sometimes those will offer clues into, maybe if there's a disruption in the database, what's going on. Now, RDS had always provided the ability to look at those logs in the console, so I can go in, click on an instance and read through what's going on in the logs, or call the API and download those logs. We recently added the ability to publish in real time to CloudWatch logs. So instead of having to download the logs and call the API, you can just say, hey, I want to publish it to CloudWatch logs, and then every single log entry goes up immediately to CloudWatch logs. Now, the great thing about CloudWatch logs is you can set alarms in logs based on patterns. So you can look for certain patterns that you know are problematic in the log and trigger an alarm. Supported today on MySQL, MariaDB, and Oracle. Postgres is almost done, and it's really easy. You just turn it on in the console, and they're shipped up there. Sometimes you have to enable, for example, in MySQL, you have to enable, if you want audit logs to go up, you have to not only sort of push them up to CloudWatch, but you have to turn them on in the engine itself. So there's some documentation about how to get them up and configured, but a really nice feature there. Events. In addition to logs, we provide what we call events with Amazon RDS. And event notifications tell you from an infrastructure standpoint, maybe there's something that you should take a look at. Maybe a backup is succeeded or an instance didn't scale correctly. And those generate events. And you can view those in the console. You can see things that happened on your instance or things that happened with your backups. And we now publish those events to CloudWatch events. So you can automatically go up into CloudWatch events. You can select Amazon RDS and select a category of event, and then you can select a target of that event. So you can run a Lambda, you can run an EC2 function, so you can basically build event rules that trigger on specific events. Now we emit events for instances, parameters, security groups, snapshots, clusters. So all of these event categories will generate a different set of events that you might want to be able to trigger on. So that's in there today. You just go into CloudWatch events and pick Amazon RDS as the source of that event. The last thing I want to talk a little bit about is optimizing costs. People run their databases and they want to say, how do I can save some money on my database costs? It can be expensive. So one of the things that we've offered over the last year or so is the ability to start and stop the database. Now this is especially useful if you're using Amazon RDS for your development and test workloads. So you've got a development database, your developers are working during the day, they're not working on the weekends, and you want to turn that database off. So we had the ability to, last year we introduced 4 single availability zone instances. Recently we've added multi-AZ instances, so you can now start and stop a multi-AZ database. Now in this case, what people would tell us is that they wanted to have their test and development database that look exactly like their production database. So if their production database is multi-AZ, they want to have multi-AZ for their test and development. And so what this allows you to do is to set it up in a multi-AZ configuration, stop that, and start it when you wanted to do it again. We also added this for Aurora database clusters. So if you're looking for Aurora for start and stop, it's at the cluster level. So just it's a little bit easier to find in the new console, but if you go to the cluster level, you can stop the cluster, which stops all the instances in the cluster, and then you can start the cluster again. So they're slightly different between the database instance and the database clusters. Now, while the instance is stopped, you're only paying for the storage and any backups that already exist. The backup window is retained, so if you had 7 days of backup before you stopped it, you'll still have 7 days when you start it again. Now we do restart them after a week, and what this allows us to do is apply maintenance, any required maintenance. So we restart them and we look for maintenance. We do trigger an event that you can catch if you want, and you can say, okay, let me trigger the event, wait for the maintenance, and then I'll stop it again. So you can do that, but we do wake them up because we have to have the database running in order to apply the required maintenance. The other thing that you can do to help save money with RDS is use reserved instances. And reserved instances allow you to get a discount over the on-demand price. So you can say, I want to reserve an M4 large in a specific availability zone, and you can get, depending on the term and whether it's up front, you can get between 40 to 60% off the price of that instance to run it for either a 1-year term or a 3-year term. So it's a big discount. They can be a little bit challenging to figure out, how many should I buy, which one should I buy. So we recently added something called RI recommendations. It's actually a feature of the Cost Explorer. So if you go into the Cost Explorer in the billing console, you can see a report, and it'll analyze, say, the last several months worth of your usage, and then it'll say, hey, based on your usage and based on your existing reserved instances that you've got, we recommend that you buy 4 more of these and 2 more of these. It'll actually tell you specifically which ones that it recommends that you buy. Now, we did introduce the ability to have size flexibility with reserved instances. And what size flexibility means is that if you buy a T2 small, or let's say an R4 large, and you want to scale that up to an R4 extra large, the reserved instance will still count, you'll still get credit for that. Now you'll get half the credit of an extra large, right? So if you've got a large, it's half an extra large, and an extra large is half of a 2XL. But it does mean that you will get credit for that. It also means that a single AZ counts as half of a multi-AZ. So that size flexibility gives you, better utilization of your reserved instances. And the last note there is that RIs are shared between all accounts in consolidated billing. So if you're using a single payer account with consolidated billing, then all of the RI benefits are shared between all instances of those accounts. Some people are surprised because they buy an RI in one account and they've got usage in another account, and like, why does this apply? You can turn off that ability in the billing console if you don't want to share, if you just want to have RI specific to one account, but most people want to take the savings that they get and apply them to other accounts. And so that's it for me. We've got a few more sessions of RDS that I do recommend. So SQL Server session tomorrow, running SQL Server in RDS. Performance Insights, if you're interested, over at the Bellagio Ballroom using Performance Insights. And then a recent session that was not on the original list, a deep dive on Amazon RDS for VMware. So that team will be there to show you all the details of running RDS in your VMware environment. So with that, I thank you, and we do have time for a few questions. So yes, right. So the question was about convertible reserved instances. We are looking at that. EC2 is currently the only service that offers convertible RIs. It's something that doesn't yet adapt to the other services, but we do hear that request.
Is there any way to stop replicating a table?
Stop replicating a table?
A single table.
So today, replication is an all or nothing thing, so it's at the instance level. We are looking for, some specific engines allow for filtered replication to filter out specific tables. So it is something that we're looking at, but currently not supported. Yeah. Go ahead.
When are you going to get Performance Insight for Amazon, for Aurora?
So Performance Insights is available for both Auroras today.
Oh, when?
So MySQL was about 2 months ago.
I thought it was only 5.6.
4 months ago, yeah.
To 5.7?
Oh, to 5.7. So the limitation on 5.7 is an issue with performance schema. So we require performance schema. So it is high on the list. I know the team is working hard on turning it on. So very soon, I hope.
Okay, thank you.
You're dropping support for MySQL 5.5 in RDS. Are you likely to drop support for 5.6 and 5.7 within the next year or two? Or?
I don't think, so 5.5 from Oracle will go out of long-term support at the end of this year.
Sorry, this is MySQL.
Yeah, so MySQL, they're not going to offer patches. So typically what we do is we follow the community, and then when they stop patching, then we stop, we eventually move people to the new version because we want to make sure that we can stay up to date with the latest patches. So they haven't announced anything on 5.6 yet. 5.6 is the bulk of, I think most users are still on 5.6, so we don't have any current plans for 5.6 or 5.7.
Thanks.
So currently, do we have any tool like Toad and like SQL Developer for RDS?
SQL Developer for RDS. So we recently released sort of the first version of a direct query editor. So for Aurora Serverless, a few weeks ago, last week, so we have a query editor built actually directly into the console that you don't have to run a separate SQL client. Over time, we will continue to enhance that. So it's pretty simple right now, but we'll eventually add that for all the engines and continue to enhance that. So we want to make definitely sort of the tools that people use to develop against. We want to make those available in the console.
Yeah, I'm actually looking for something to see the query plan and see like what type of scan or what type of joins we are using with the SQL.
Sure. So query plans are coming to Performance Insights. So Performance Insights, today you can drill down on the query, and that will also be adding the query plan. So you can find the offending query, and then you can see the query plan. Then you'll be able to take that query and then run it in the query editor, and you can try it out and create an index. Over time, yeah, we'll be adding that sort of capability.
How about data modeling tool like Irwin or ER diagram kind of things?
It's a good suggestion. I wouldn't. I don't think we have anything planned right now, but it's a good suggestion. We are. I don't know if you've used the Cloud9 environment in AWS, so we're interested in finding ways to plug into that. So, but a good suggestion.
Okay, thank you.
Go ahead.
How soon will read replicas be available for SQL Server?
I think we're targeting the first quarter of next year. We introduced recently, so the new version of SQL Server, I think the latest edition of SQL Server, when you turn on multi-AZ configuration, we're actually using always on behind the scenes. We used to be using database mirroring, and we switched that to always on, but that's just for multi-AZ. But we'll use that same technology in order to support having the secondary be queryable, basically, to get that read replica functionality. So it's coming soon.
So our database has been up for like a couple of months now, and I think we're doing mirroring. So will we need to convert that over to always on?
A good question. Well, I'll have to follow up. I know if you create a new one with the latest version, then you'll get always on, but I'm not sure of the path to move from mirroring to always on. I'll have to follow up with that. And if the SQL Server session would be a great time to go ask those guys. There's one tomorrow on running SQL Server, so great.
Actually, piggybacking off of that question with SQL Server, the multi-AZ support. So in Northern California, I think that's the only region that it's not supported. Is there any timeline where that is going to be supported?
We've talked about that. So SQL Server, I'll have to get back. I think always on makes that better because mirroring we had to have a special configuration that wasn't available in that region. And so I think it should be coming. But another great question to ask the SQL Server guys tomorrow.
Okay,
So
thank you.
Yeah.
For RDS on VMware, will backup part supported and will that go to S3?
To both local and to S3, yes.
So when I take a backup on VM environment, it will go to S3.
So you can store it locally or you can have it pushed up to S3. So it can be stored in the local vSphere storage or you can have them pushed
Both
up to S3.
configurations will be-
Correct. And then you can actually push them up to S3 and then you can restore them into AWS Cloud.
Thanks.
This is regarding the upgrading and database. What is the best practice to upgrade Postgres 9.4 into RDS, Postgres 10? Is it a DMS would do the job, or you have to do any other way to do upgrade into AWS if I'm planning to migrate on-premise to cloud?
Yeah, so one is, we only support single version upgrades. You can't jump a version, so you'll have to go through multiple upgrades. MySQL and I think MariaDB allow you to do a major version upgrade to the replica, but Postgres doesn't let you do that. You can only do that with minor versions. So, yeah, other than scheduling some time to work around it, yeah, restore backup, and then get that up and running.
DMS supports the DMS, your data migration service tool, does the job migrating up to from 9.4 into Postgres 10?
Yeah, you should be able to use DMS and change data capture to move data between the two instances. So you'll still have to have some time to switch over, but yeah, DMS supports Postgres as both a source and a target.
Okay, all right, cool, thank you.
How do we get access to preview of Oracle read replica? Is that available for everybody or Oracle read replica?
Let me. I think we need to whitelist. I think it's it's an invitation right now.
Okay.
But yeah, we can definitely get some information and get you in the preview.
I work for Nike.
Okay.
Another question is like, you don't have currently filtering out tables. What happens if we change the data on the second side? Basically, we use legacy application, which stores IP addresses in the tables. We want to override on the read replica side and use it for some other purpose.
So I don't know if that will specifically for Oracle or
Specifically for Oracle.
yeah, I'm not sure. So in MySQL and Maria, you can make the replica writable. Now it's easy to break the replication, right? Now you're kind of in unsupported territory, right? You can cause conflicts. But I'm not sure about Oracle. I would, if you stop by the databases booth at the Expo in the Venetian, there's lots of Oracle folks who will probably be able to dive deep on that one.
Thank you.
Thanks for the presentation. The question is about RDS on premises. Would that use the same control plane and monitoring plane as the one we have on AWS?
Yes, that is the goal. That is the goal, that it's managed just like you managed in AWS today. So same control plane. It's just that the compute is running in, on premises.
So I could use the command line, the API, CloudFormation.
Yes, all the same features are, the goal is to support all the same feature set.
Cool. Thank you.
Hey, so can we expect the provisioned IOPS to go up just like for EBS, to be bumped up, the maximum provisioned IOPS? So are there plans to increase this for RDS as well?
The IOPS?
Yeah.
So technically, it's actually not problematic. We haven't really found anyone yet who's pushing 40,000. But if we get that demand, then we can up it, right? I mean, EBS now went to, they have 64,000, I think, on a single volume. So it shouldn't be a problem. It's not technically a problem. It's just we haven't really gotten a lot of demand to go beyond 40,000. But if we get that request, we can certainly make that happen.
So is there a way that we can contact support just to increase this limit?
I don't think it's not a coded limit. I mean, I think it's a hard limit right now in the service, so it's not a variable that we can change. But we're happy to work with you and figure out a way if you're running into that IOPS limit.
Okay.
Yeah.
What is the best way to point-in-time recovery for the object level? Like if I want to go for the table level point-in-time recovery, what is the best way or option we have in RDS?
To back up at the
Point-in-time level recovery for the table.
Okay, so you're talking about sort of a in general, all the native backup tools will work with RDS. So some people will use Percona Extra Backup, or they'll use PG Dumper, or so all of those will work, and they usually have some options that you can save or restore a portion of the database. There's nothing built into RDS because we don't really work at the instance level, right? The volume is, the backup is at the volume level. So you'd have to use a native database tool. MySQL or SQL Server has that as well.
I think Aurora we have backtrack option, right? And even Postgres we have the backtrack option.
So backtrack is in Aurora only. Uh-oh, they're about to kick me off. But I will be out. I will answer lots more questions out there. So
sure,
just grab me and we can talk more about that.
Okay, thank you.
All right, thank you.